Now we're going to learn how to get the derivative of the sine and cosine functions. So we need to learn how to do d sine x dx, or use a sine x prime, right? Okay, that's the derivative of the sine. And also we're going to learn what is the derivative of a cosine. Before we go to the detail, I would like to review a little bit about the limit we learned earlier. And I want to draw you a quarter of this unit circle with the radius 1. Okay, here's a 0, here's a 1, and here is the 1 in the y coordinate, and here is the 1 in the x coordinate. So that's a little circle. Okay, and the angle is tiny, and this arc is let's say that's starting from here and up by delta x. Now, if I enlarge this, let me just use another color to show. Okay, if I enlarge this, make it big, okay, that will look like that. And then this is the delta x, right? And this is 90 degree. And the vertical part, and this is, because that's the sine of this angle, so that is the sine delta x. And what about here? What about this little piece? This little piece is actually 1 minus this part. This part is cosine, so that's 1 minus cosine delta x, right? If we enlarge that, and we get this. And then we learned earlier, limit when delta x approaches to 0, that means when this shrink, and approaching to here, it's tiny, tiny, tiny. Then we have a sine delta x, which is the vertical part, over delta x, which is the curved part. It's 1. The limit is 1. So the length of this and this, the ratio approaches to 1 when delta x approaches to 0. And also when delta x approaches to 0, this part, 1 minus cosine delta x over delta x, which is the ratio of this versus delta x that approaches to 0, because when you shrink, you move this point all the way down to this point. So you keep going down, and then this little piece approach to 0, but the ratio between this part and this part is getting close to 0. That's what we did earlier. We keep this in mind, and then we can derive this and to find what is sine x prime and cosine x prime. Let me get another pen. All right, so ready? All right. Now, how do you get a sine x prime? Sine x prime, by definition, is limit delta x approach to 0, and here's going to be sine x plus delta, right, minus sine x over delta x, right? That's the definition of the derivative. And then I'm going further. Delta x approach to 0. Now, if you learned a long time ago, if you do sine alpha plus beta, I don't know if you remember this, that will be sine alpha cosine beta plus cosine alpha sine beta. That was in pre-calc 2. Okay, so now we have a sine x plus delta x. This is alpha, this is beta, so we just plug in like that. So I get a sine x cosine delta x plus cosine x sine delta x. So this two term was the expansion of that, and then I'm going to minus sine x at the end, again, divided by delta x. Okay, so limit delta x approach to 0. Okay, I'm going to combine two terms, which is this one, because I have a sine x, and here's the sine x. So I put sine x, I factor this sine x out. Okay, and inside I have a cosine delta x minus 1, isn't it? Yep. And then I go plus cosine x sine delta x and divided by delta x. All right, now I noticed there's something looks familiar. Here is sine delta x over delta x. So let me write that first. This over this. So I get a cosine x sine delta x over delta x. So far, that's this part, right? And this one, I have a cosine delta x minus 1, but we know 1 minus cosine delta x. So I just take the opposite sign of it, and then I get a sine x 1 minus cosine delta x. That's the one we did earlier, and we know that, okay? So that is the limit you're trying to find. And since when delta x approach to 0, sine delta x over delta x approach to 1, right? And then we only have a cosine x, okay? Or we can say cosine x multiplied by limit delta x approach to 0, sine delta x over delta x. Okay, I'm going to minus, and I take the sine x out. So sine x, because this has nothing to do with the delta. So I go limit delta x approach to 0, 1 minus cosine delta x over delta x. Okay, now you get this term we know, and you have this term we know, because this one we know that is 1, and this one we know that is 0, right? I just give you the little bit review at the beginning. So that would be, because this approach to 0 multiplied by sin x, so that part is 0, and this part is 1, so the answer will be cosine x. All right, so what does that mean? That means if you have sine x, you take the derivative of it, you get a cosine x. Okay, can you remember this? This is very, very important. Sine x prime is cosine x. Okay, so how do you use this one? How do you use this? Keep this in mind. I just keep writing this because I think this is super important. I just keep that at the top. Let me ask you give you some quick examples. You're gonna see how do we do that. Okay, if you have a y equals 5 sine x, what is y prime? Y prime, this 5 stays as a 5, and the sine prime is just cosine x. So you get a 5 cosine x. Okay? And what about this? What about if I ask you y equals x squared plus sine x over 2? It's a little bit complicated. It's just the addition of two expressions. So we can take the prime of this plus the prime of that. So therefore, y prime will be, quick review, if you bring 2 down, so you get a 2x. So that's a prime of that. And then you're going to plus. So this is actually 1/2 of a sine x. And sine x prime is cosine. So you get a cosine x over 2. Okay, that's how you use that. Every time when you see sine x, you take a prime, then you just make it to be cosine. All right, so that is the first thing we learned, and how to get the sine prime, and how do you get the cosine prime? There's also a way to prove it. Okay, so I think you can do the same thing because we know cosine x. If you want to take the derivative of that over versus dx, you can prove it, and you can use it limit delta x approach to 0, then you're going to get a cosine x plus delta x minus cosine x over delta x. Okay, so that is something you should know. But then you can use you can use the formulas. Um, sorry, you can use the formula of the I think it's something that you're learning. I believe that was in uh, the pre-calc 2. Okay, so I'm sorry that I think I get something wrong here. So cosine. Okay, okay, so cosine. If you remember that, if you have a cosine alpha plus beta, alpha plus beta, you're gonna get a cosine alpha, cosine beta minus opposite sign, sine alpha, sine beta. So again, this is in your pre-calc 2. Okay, and then we're going to put that in here, limit. You can see what I'm doing here. Let me just move this around. So I move this so you can see. Yeah, okay, so that's going to be limit cosine alpha plus beta. So that's going to be cosine, sorry, here I got it right. Limit delta x approach to 0. So I get a cosine x, cosine delta x, right? And then I'm going to minus sine x, sine delta x. And then I'm going to minus cosine x. And then divided by delta x. Very similar, I'm going to combine this term and with this term. So I get a limit delta x approach to 1, sorry, 0. The denominator is delta x. And the numerator, because I have a cosine, so I get a cosine x, and inside I get a cosine delta x minus 1. Now that's the form we like, right? And I'm going to minus sine x, sine delta x. Okay, now did you see this is sine delta x and then delta x? So I got a negative sine x limit delta x approach to 0, and the numerator is, because the sine x is out, so I have sine delta x over delta x. Okay, then I'm going to minus, because I still like the 1 minus cosine part, so I'm going to go minus limit delta x approach to 0, and then I take a cosine out, so cosine x, I'm sorry that I should leave a little bit more space, and then inside I get a 1 minus cosine delta x over delta x. Okay, now this part is 1, and this part is 0, right? That's what we learned earlier. Therefore, did you find something interesting? You only have a negative sine x. Okay, so what does that mean? That means cosine x, if you take the derivative of it, you should get a negative sine x. And do you remember what do we have for sine x? If you take the derivative of it, you get a cosine x, isn't it? Yep. Okay, so those are the two most important things we are learning here, because we know for the sine and the cosine, we know how to get the derivative. Okay, let me give you two more examples, okay? The first one, y equals sine x plus cosine x. What is y prime? Y prime will be sine x prime, which is cosine x. Okay, cosine x is negative sine x. That's it. It's easy, isn't it? All right. Now, what about if I give you y is 5 cosine x plus pi times sine x? What is y prime then? Okay, cosine x prime is a negative, so it's a negative 5 sine x. And the sine x prime should be cosine, and the pi is just a number, so it's going to be pi cosine x. That's it. That's your answer. So I don't think the question is going to be super difficult. for this type of thing. So those are the most important formulas we learn for taking derivative. I hope this time my explanation is clear. Thank you.